All right, hello. This is Chapter 2, Section 3. We're going to start talking about some basic statistical tools that you have to analyze data. And the first one is called the five-number summary. Now, looking through the textbook, I don't actually see them ever say the phrase five-number summary, but this is very common, and effectively, they are talking about the five-number summary when they mention the things that they're mentioning. So, if you have a collection of data, so you've done some study, you've collected data on a variable, and you've got all these numbers, well, we'd like to summarize them, right? What we saw in a previous video is that it's kind of difficult to see patterns or make conclusions based on just a big list of numbers. But if we can start to organize or visualize the data in some way, it's helpful. And one thing that we can do with a bunch of data is try to come up with summary numbers, numbers that represent the data set in some way. Now, there are some pitfalls to this, which we have to be careful about, but they are very useful tools. Here's the first one. So the five-number summary is this. We have the minimum, first quartile, and don't worry, I'm going to explain these. The median, also known as the second quartile. The third quartile, and the max. So what I actually want you to do right now is imagine the numbers 1 through 100. Okay, so you're just thinking of the numbers 1 through 100. We're starting at 1, all the way to 100, right? Think about the smallest number. Well, the smallest number is, of course, 1. And the biggest number, so I should write the full word out, maximum. The biggest number is 100. And all of our numbers are in order, right? What's the very middle? Yeah, 50, right? Now, thinking from 1 to 50, the first half of our numbers, what's the middle of that? 25. And then from 50 to 100, the second half of our data, what's the middle of that? Yeah, 75. Okay, so what we're going to do with the five-number summary is every time, no matter what our data is, no matter where it starts and ends, and no matter how many numbers there are, right? There might be much less than 100 numbers. There might be much, much more than 100 numbers. We're going to find these spots, right? We're going to find the smallest value, the minimum, or usually we just say the min to save some time, the largest value, the maximum, the max, the middle, which we call the median. You think about like you're driving in the road, the double yellow or the dotted yellow in the middle, that's the median, right? It's the middle of the road. And then the quartiles are the halves of halves, right? We're cutting it. Look how many pieces we cut it into, right? 1, 2, 3, 4. We cut it into 4 pieces. If you've cut something into 4 pieces, you've quartered it, right? A quarter is 1/4 of something. What we're doing is quartering the data. First, fourth, second, fourth, third, fourth, fourth, or 1, right? So when we say the first quartile, we mean the top of the first chunk that we've made. So 1/4, 1/4, 1/4, 1/4. Okay. The median, the middle, of course, is going to be the first fourth and the second fourth. That's 2 out of 4 or 1/2, right? So you can say the second quartile or the median. The third quartile is just the top of the third piece. And then the maximum, of course, is the top of the fourth piece, right? We don't say fourth quartile. So we have the first, second, and third quartile, but normally we say median instead of second quartile. For this to work, we needed to have placed all of our numbers in order from smallest to largest. If you haven't done that, you cannot do this five-number summary. Before you can do this, you must first sort smallest to largest. Okay, so there's 5 numbers here: the minimum, first quartile, median, second quartile, and maximum. Sometimes we'll write it like this. We'll have, so we have min, first quartile we call Q1, median is Q2, third quartile is Q3, and max. So those are your 5 numbers, and it's the 5-number summary of a set of data. It is the center of the data. Again, you have to have ordered the data in order to do this. Let's look at an example. There's something in particular about the median, because the middle might not actually be one of the numbers in the data set. And the min and the max, of course, are going to be, but when you start cutting up the pieces, the quartile Q1, Q2, and Q3 might not actually belong to the data set, but they're still cutting it up. So let me show you what I mean. Using an example from your book, we are given 1, 11.5, 6, 7.2, 4, 8, 9, 10, 6.8, 8.3, 2, 2, 10, and 1. Okay, now, what's the first thing you got to do? Right, we got to put it from order from smallest to largest. Now, are we going to do that by hand? No, don't do it by hand. Use a calculator, right? Remember, I showed you with the spreadsheet how you could enter data. Ooh, ignore that data. You could enter data, and then once you had it highlighted, you hit data, and then this is not an option right now because I don't have any data entered in the sheet, but you hit sort range, and you can sort it from smallest to largest or largest to smallest. However, I'm not going to do that again this time because, the textbook was kind enough to do it for us. So in order, we have 1, 1, 2, 2, 4, 6, 6.8, 7.2, 8, 8.3, 9, 10, 10, 11.5. Okay, now let's count how much we have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. So I'm going to say n is the number of data points I have, and n is 14. Okay, now, what's the minimum? Okay, the minimum is the smallest number, so the minimum is 1. What's the maximum? That's the biggest number, so that would be 11.5. Now, if you do 14 divided by 2, you get 7, right? So 14 divided by 2, we get 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I've cut the data exactly in half, right? There's 7 in the first half and 7 in the second half. But then, where's my actual median? Where's Q2? There isn't one, but that's okay. We'll just average these two values right here and get our number. So remember, for the average, you're going to add up how many there are and then add up all the pieces and then divide out by how many there are. The textbook did this for us already. So 6.8 plus 7.2 actually ends up being 14. So 14 divided by 2 is 7. So coincidentally, this is a coincidence, or possibly the textbook authors thought they were being cute. But the median, Q2, I'm going to write it in red. So Q2, which is the median, the middle, is 7. Okay, now, I want to change this color for a second. Green. Look at the first half. So from 1 to 6.8, we have 7 numbers. This is the first half. The middle of this, remember, we're going to cut the data into 4 pieces, right? So far, I've cut it into 2 pieces, the first half and the second half. And then if I kick a half and a half, I get a fourth, right? A quarter. So we're going to cut this in half. So 7 divided by 2 is 3.5. So what does that actually give us? That means that this number is Q1, because we have 3 on the left, 1, 2, 3, and 3 on the right, 1, 2, 3. So this is exactly in the middle. So Q1 is 2. Same thing over here, different color this time. Let's do orange. Oh, well, I should. I can't offend anybody with orange and purple, right? With Clemson colors, because we're Coker we're Cobras, right? We don't care about USC and Clemson here. Who am I kidding? This is South Carolina. Like, all right, I'll do garnet and black later. Okay, yeah. All right, so this 7 here, again, we're going to have a middle number, which is going to be this 9, because look, we have 3 below it and 3 above it. So this is quarter 3. And now what we've done is cut the data into 4 pieces. So our minimum is 1, our first quartile is 2, our second quartile is 7. Sorry, I'm just checking my timer. I've got 4.5 minutes left on this video. I'm trying to keep it at 15 or below. 9 is the third quartile, and then the max is 11.5. Okay, so we're separating the data into 4 pieces. Now, with that, we can use this to make decisions about whether or not some data is extreme. Right? So you think about like, let's say you were counting the number of home runs for a team in a season. Now, when I think of home runs, I know this is getting quite old now, actually, but I think of when I was an early teen and Mark McGwire and Barry Bonds were in a home run contest in the MLB. And so anyway, so if you have a team, right, and like, yeah, this guy, we have number of home runs for the season. Like, first player's got 2 home runs, next player's got 0 home runs, next one's got 1 home runs, and then Mark McGwire's got 13 home runs, right? So if you were to try to look at the data, all of the home runs for all the players on the team, Mark's kind of standing out, right? And Barry on his team, Barry would be standing out in his team. Those are what we call outliers, right? They're going to kind of mess with our data set because they're so much different from the rest of the data that we've collected. Now, the tricky part is, how do we decide when a value is actually extreme enough to call it an outlier, right? When do we say, like, that's really unusual? Maybe it's actually not unusual. Maybe by calling it an outlier, we're affecting how we view and how we analyze and present the data. We like kind of ignore these very big or very small values when we actually shouldn't. We need to come up with some type of rule that we can follow, right? Now, is that rule going to be infallible? No, but it's at least consistent, right? And so we actually have a rule for deciding whether or not a value is too small or too big, and we'll call it an outlier. That doesn't mean that we're going to throw it out or ignore it, but we are going to identify it as an unusually extreme value. So here's our rule for that. It's called the 1.5 times interquartile range rule. Now, what is the interquartile range? That is Q3 minus Q1. In other words, it is the distance from here to here, right? This distance is the interquartile range. Okay, so we're going to kind of use that as a reasonable yardstick, a reasonable measuring stick to decide whether something is too big or too small. Now, how does that work? Well, what we're going to do is, taking this same measuring stick from Q1, go that same distance out this way, and from Q3, go that same distance out the other way, right? And so what we have is, if some value, so I have some x value, if it is smaller than the minimum value, or sorry, not the minimum, I'm sorry, I apologize. The first quartile minus 1.5, oh, maybe you noticed my mistake earlier. I said I illustrated, I'm sorry about this. I illustrated this distance and I said, this is our measuring stick, but that's not quite our measuring stick, is it? It's 1.5 times that is our measuring stick. Sorry. So anyway, so that's our measuring stick. 1.5, this distance right here, and then half of it again, right? So 1.5 times the interquartile range. So if we're looking at Q1 and we subtract 1.5 times IQR, so here it is, this is 1.5 times the IQR. This is still just IQR. And here, I need to erase the n equals 14. This is 1.5 times the IQR, right? So how far below are we going to go and how far above are we going to go? Starting at Q1, go 1.5 times the IQR, and starting at Q3, go 1.5 times the IQR. And this is going to be our cutoffs, right? If we're less than this, that's an outlier. And if we're greater than this, that's an outlier. And there's my timer. I'm going to wrap up this example and then we're going to stop on this video. So if X is less than the first quartile minus 1.5 times IQR, then we have an outlier. And if X is bigger than Q3 plus 1.5 times the IQR, that is an outlier. And we will stop there for this video. I'll see you in the next one.